So we left off with Casey enlarging the C for the door of her bedroom. And we related the two heights to each other. And we knew that if the figures were actually going to be similar, that the widths would have to relate to each other. So we have height of the smaller figure related to the height of the larger figure. And we have the width of the smaller figure related to the width of the larger figure. So we're going to start with this proportion, which is an equation where two ratios are set equal to each other. 8 is to 20, and 6 is to x. So this is an important setup. So step one is to start with a proportion equation. And we're going to use the fraction busters technique to multiply by the lowest common multiple of the two denominators. Well, one of the denominators is a variable, so we're simply going to multiply by both denominators, in this case 20 and x, and it's the multiplication property of equality that allows us to do this. X over x equals 1, so I'm left with 6 times 20 in the first simplification step. 20 over 20 equals 1, so I'm left with 8x in the second. So 8x equals 120. The division property of equality says I can divide both sides by the same non-zero value. In this case, that's 8. Once again, 8 over 8 is 1. So I'm left with x equals 120 divided by 8, which is 15 units. So let's use that same proportion followed by eliminating the denominator by reducing to 1, followed by the simplification step. So 3 steps to successful setups in these similarity type problems. In 3-16, we're asked to use observations about ratios between similar figures to answer the following questions. Assume one triangle has length 6, 7, and 10. So go ahead and draw the triangle with lengths 6, 7, and 10, and another has lengths 3, 4, and 5. And are these triangles similar? So you're really going to compare all 3 corresponding sides, or corresponding pairs of sides. The smallest are 3 and 6. That's a ratio we're familiar with. That equals 1/2. The largest are 5 and 10. That's another ratio we're familiar with. There's another way to express 1/2. So far, so good. But these two middle would also have to have a ratio of 1 over 2. So is 4 over 7 equal to 1 over 2? Well, the means equals 8 and the extremes is 7, or vice versa. The extremes is 8 and the means is 7. So no, not equal to 1 over 2. My explanation is these two triangles are not similar because all 3 pairs of corresponding sides are not in proportion. 2 are, but that's not enough for similarity. So let's go over the definition for similar. And I'm going to put a star next to this. This is an important definition. All pairs of corresponding angles are congruent. That is to say, corresponding angles have the same measure. And all pairs of corresponding sides are in proportion. So 1 and 2. Both of these statements are necessary for the definition of similar. And doesn't writing the definition of similar sound like something you might have to do on an assessment? So I suggest you break that down and take a look at it often through this unit. Knowing the definition of similar is an important part of this unit. And let's take a look at B. If these pentagons are similar, what are the values of x and y? Well, they've told us that these are going to be similar pentagons. And we can tell that 8 and 24 are corresponding sides. Y corresponds with 18. And 11 corresponds with x. So 8 is to 24. This is my zoom factor or scale factor. Those terms are interchangeable. And the nice thing about scale factors is that we can actually reduce them. So this is a 1 to 3 scale factor. This pentagon is 3 times larger than the smaller pentagon to its left. So we already know that y is 6, and we already know that x is 33. So the important part is not really the arithmetic. The important part is actually setting up the equation to show that. So, small figure to large figure. Is the direction I intend to go. So I'm setting up my small to large scale factor. So 8 is to 24, that's the same as 1 is to 3, as y is to 18. And that's my proportion equation for this first missing variable. So step 1, set up the proportion. Step 2, bust the fraction. Step 3, simplify. So I'm going to multiply by the lowest common multiple of 3 and 8. And I'm lucky in this case because 3 is a factor of 18. I said 8 and I meant to say 18 for this denominator here. I'm lucky because 3 is a factor of 18. And 18 thirds reduces to 6. 18 eighteenths reduces to 1. So I'm multiplying y by 1, which has no effect on y. 6 times 1 is 6 in my simplification step on the left, equals y. And let's set up a proportion for x. I'm using small figure to large figure equals 11 to its corresponding x. I'm going to bust the fraction by multiplying by the lowest common multiple of the two denominators. I have x multiplied by 1 equals 11 multiplied by 3. So x is 33. These are both the results we were expecting. Now the interesting thing about scale factor is that all of the linear measures are increased by a factor of 3. So we should be able to take the parts of this perimeter that we know, 8 plus 6 plus 11, and we should be able to multiply that by 3 to get the parts of the larger figure, 24 plus 18 plus 33. So let's check. 25 times 3 equals 75. Is 24 plus 18 plus 33 also 75? 24 plus 18 is 42, plus 33 equals 75. So yes, that was a successful calculation. So use these 3 steps to set up similarity problems, and use this definition to justify or to check for similarity.